Today we're going to be doing a Pythagorean Theorem math problem. So let's get into our problem statement. So here's our problem statement. In the diagram, each of the three triangles, so our first triangle is QPT, so this is our first triangle here. Our second triangle is QTS, so this would be our second triangle here. And finally our third triangle is QSR, so this is our third triangle, are all isosceles. So since they're isosceles, that means this length will be equal to this one will be equal to this one, and this one will be equal to this one. So these are all three isosceles, and they're also right angled, so they all have a right angle. With the angles QPT, so this angle here is equal to QTS, so this angle here is equal to QSR, and those are all equal to 90 degrees. So the combined area of all three of these triangles is up to 56. So the combination of this triangle area, and this triangle area is going to be equal to 56. So if QP is equal to PT, and that is equal to K, so what is the value of K? So we're going to be looking for the value of K here. And our possible answers for this solution is A, which is the square root of 2, B, which is 1, C, which is 4, D, which is 2, and finally E, which is 2 to the square root of 2. So just before we get into the solution for this video, try solving this problem by yourself. And if you have any struggles, then feel free to comment down below. And we're going to be getting into our solution right now. So for our solution, first, what we're going to be doing is we got to find out the area for each one of these triangles so we can get up to that 56. So what we're going to first do is we're going to find out the side lengths for each one of these. So we already know that this here is going to be equal to K, and this here is equal to K, but we don't know what this length here is. So the length from Q to T, we don't know what that is. So to find out, what we're going to do is we're going to use the Pythagorean Theorem. So that's going to be equal to K squared plus K squared is going to be equal to QT squared. So here we can see we did that. So QT squared is equal to 2K squared, and then what we're going to get for QT, we're going to get QT is equal to the square root of 2K. So the line QT is equal to the square root of 2K. So now from there, we know what this line is, and we know this one, since this is an isosceles triangle, we know that this is equal to the square root of 2K, and this is equal to the square root of 2K. Now what we're going to do is find the length of QS, and in order to find that, we just do the Pythagorean theorem again. So this is equal to the square root of 2K, so we're just going to do the square root of 2K squared, plus the square root of 2K squared again for both of these. And then from there, we're going to get is equal to QS squared. And once we simplify that, we're going to get QS is going to be equal to 2K. So QS is going to be equal to 2K. So I'm just going to write the value for what we got for all of these. So we got this length here, we got it as square root of 2K. And for this length here, we got this as 2K, and we already know that that is K. So now since we have the lengths of all of them, it's going to be easy to find the area. So let's just find the area for all three of these triangles. So first we're going to look at the area of the triangle QTS. So let's go over to QTS and find out the area of this. So to find the area of a right angle triangle, all we have to do is half times base times height. And we know that so we know that our base is going to be equal to TS, and TS is equal to the square root of 2K. And then our height is also the square root of 2K, since it's an isosceles triangle. We're just going to multiply all that, and the area for the triangle that we get for QTS is equal to K squared. So this area is going to be equal to K squared. And now let's find out for the area of the triangle QSR, so this big triangle here. And we know we're going to just do the half times base times height again. And our base is equal to 2K, our height is equal to 2K. So that means the area of the triangle QSR is equal to 2K squared. So now we know that the area of this triangle here is K squared. We know that this area triangle is 2K squared. And finally, for the small triangle, let's just find that. For the small area triangle, for QPT, same thing, half times base times height. And we know that our base is equal to K, our height is equal to K as well. And finally, for the area of the smaller triangle, we get half times K squared. So these are all the areas we got. So now it's going to be very simple in order to find our K value here. So from here, area of the triangle, all three of the sums is equal to 56. So we already know that. And then what we're going to do is we're just going to substitute every single one of these. So half times k squared, which we have here, so this one is half times k squared, plus the area of this one, which is k squared, plus the area of the bigger triangle, which is 2k squared, is all equal to 56. So once we simplify this and solve it, then we're going to get k squared is going to be equal to 16. That means just the value k is going to be equal to 4. And that means the answer for the solution is going to be equal to c, which is 4. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our next math problem.